Welcome, everybody. Today we are working on Unit 9. The topic for this unit is talking about how to create classes and objects in Python. Really, all of this is based upon a higher level concept. The higher level concept is kind of this overriding principle called object-oriented programming, which has kind of been the main thrust of programming, I'm going to say maybe since the 80s or 90s, and is really kind of designed to accelerate our workflow, to have us not repeat our code, and to make programs generally easier to use, and to be able to, basically take code that you've created before and reuse it in meaningful ways in other programs. In my Brave browser, I have the materials pulled up here, and I'm going to be going through basically these first 6, 7 bullets here. We will leave polymorphism and inheritance for next week. And we'll talk about these other concepts during next week's session, where we'll take it just a little bit deeper. Object-oriented programming, and you will see this acronym OOP, kind of like oops, but oop, basically. And what this indicates is these techniques that we're about to learn. The nice thing about Python is that it is an object-oriented language and allows for the same types of things that we would do in other high-level languages. And as it indicates here, it says it allows you to structure your code using classes and objects for better organization and reusability. Let's take a look at some of the advantages here. The one advantage, of course, is the fact that when you create classes and objects, that it gives you very clear and meaningful program organization, and allows you to make many copies of code and use it as independent entities in your program. So it gives you very clear structure. It also makes it a whole lot easier to both reuse the code, also to debug the code, because you know where the program flaws would be located, basically in the class definitions. And also, as a result, it's easier to fix things because you're fixing them in one spot instead of multiple spots, especially when you're reusing code. We use this principle that we call the dry principle, which is the don't repeat yourself, right? And this is kind of something that really has been available to us ever since we started working with functions. It basically allows you to take things, build them, and use them over and over again without having to recreate all the code required to perform the steps or the actions or whatever it is that you need to do to get your program problem solved. And the little tip they throw in here, it says that you should avoid writing the same code more than once, move repeated code into functions or classes, and reuse it. Now, we've already learned the function approach and how we can apply that to run a function multiple times. Now we'll see how it applies to classes and objects. Really, these two terms, like once you really kind of understand what they mean, it will unlock a lot of things within programming, and not just in this language, really in any language. The two key principles really are that we have classes, which really are basically a blueprint for building an object. The object is the thing we built based upon the blueprint. And the analogy of using a house blueprint is really a good example, right? Because I can create a blueprint for a house that gives you all the specifics, the size of the house, how big things should be, how to, what materials to use, the whole bit, right? But that doesn't make a house, right? You actually have to take the blueprint, and if you build the house based on that blueprint, now you have a version of that blueprint in reality, and that would be the object. And that's how code works as well. So we will write code that will define the blueprint, which is a class, and then we will create the object based upon that blueprint. And every time we create that object, it will be a unique version of that blueprint. And the one analogy I always give with that is, think about going into a subdivision and you drive around, and sometimes you're like, wow, these houses are all kind of the same, right? They have the same basic look and design. Some might have different siding, some might have different windows or a different roof, or one might have a garage and another might not, but the houses often are the same. And the reason why is they use the same blueprint, and it's all the other details or data that goes with the object, in programming, that makes it unique unto itself, but it's still based upon that same blueprint. Um, and let's go through this W3 stuff here to help kind of define all this. And it says, these are the two core objects in object oriented programming for sure. And it says a class defines what an object should look like, and an object is created based on that class. So, for example, the class we might have might be fruit, right? And fruit have certain things that are in common to all fruits. But when we create fruit, then we can create fruits that are very different from each other, really because of their features, right? So these are all fruits. They belong to the fruit class, but definitely an apple is not like a banana, and a banana is not like a mango, and a mango is not like an apple, for sure. Same thing with cars, right? Cars have a lot of things in common. For example, they have a motor and a body and seats, and things like that. But you have to admit that there's different brands and types of cars. And for example, you could have a Volvo or an Audi or a Toyota or a Ford or, whatever, right? It doesn't really matter. They're all basically cars, but they're different types of cars based on the car class. When you create an object from a class, it inherits all the variables and functions, or when they're inside, we call those methods, by the way, defined inside that class. So, we will build objects. A really important aspect of it is that objects have data, right, that they hold, that make them unique. Like, for example, if you think of humans as a class, and then we become the object, the instantiation or the creation of that class off of the blueprint, we're all unique. We have our own birth date, we have our gender, we have a name, we have like height and weight, and whatever, all of those things that make us unique. Yet we do share commonalities with all humans. Like, humans walk and talk and sleep and eat, and they do the same actions, right? And those would be like the functions. So we have data, which we think about as variables, and then we have capabilities, which we think of as functions or methods. All right. And so what we're going to do now is we'll dig into each one of these topics just a little bit more. And we kind of will reiterate some things over and over again, and that's really for reinforcement and also kind of follow the flow of what they have here. And they indicate that Python's object oriented, which we already talked about. And this is really an interesting thing because it's also true for a few other languages. And the one that always pops in my head is JavaScript. We can say the same thing about it, actually, where almost everything inside of Python actually is an object that has properties and methods. A class, it says, is like an object constructor or blueprint for creating objects. And we've talked about this already in this little lecture. When we want to create a class, we just very simply use the class keyword, and then we name it. I want you to notice here that there's no parentheses after it, right? We just indicate a class and we say my class. A couple interesting things about this that isn't necessarily talked about here is that a class definition can exist inside of a program, right? That's one approach for doing it. So I can create a program like I normally would, and then somewhere in the code, probably towards the bottom somewhere or near the top, whatever you choose, you can put in a class definition that defines the blueprint, and then the program can create objects off of that blueprint. Another technique is, and probably more common in programming, especially for reusability, is to create the class as a separate file. And usually you put it in the same folder, at least at this level of programming that we're doing. And you can still build objects in your program from that class file by virtue of the fact that it's in the same folder. Here they have a super basic example of a class, and and they'll just indicate it, given a name, and then inside here we have a variable that's set. So this class, anytime I make a version of it, that'll have a variable inside it with x set to 5. And we really have no idea what this means at this point, right? Because this is kind of like a basic thing. But we create the class, and this is the blueprint, right? Normally, and it depends on what you're building, obviously, we wouldn't necessarily have a hard coded value here, right? But we might have a starter value, like if we're expecting a numeric value, we might start with 0, that type of thing. um, then what you can do is you can use um, the my class constructor basically to build the object. So let me just hit these couple of examples here just so you can see. So if I create the class and then I try to print it, what you will get on the screen is basically an indication of what type of object it is. And this is kind of an interesting output. But if I see something in a program and I don't know what it is, throwing the name of it in a print statement is actually a good way to tell you what it is. So like all this is doing, it's not like creating an object or anything like that. It's just telling me what my class actually is. And it's indicating that it is a class file. It's not an object, but a class, right? Now we can go ahead and we can create an object. And what they're doing here, mind you, is they're calling my class. And I want you to look at the syntax here. There's parentheses after it. And this approach or this thing is what we typically call a constructor, right? So it looks like a function, but it calls the class and says, hey, can I have one of those? Make me one of those, right? And then if you're making one, you need to name it. So in this case, P1 becomes a class with these features. Now, mind you, it only has one data point in here, so it doesn't really have much. But then when I want to print out this object that I've just created, so this is the object, right? Notice how it has a unique name. I can then reach into it with .syntax and grab one of its properties or data fields, basically, and then put it back up on the screen. So if I, for example, added a Y to this, right, and set that to, I don't know, 8, for example, and then I print out the Y, you'll see that it will print out both the 5 and the 8. And it takes a moment, but that object now carries both of those values with it, right? And I can do things with that. I can do math with it. I can, use it to output to the screen, whatever task we need to do programmatically. It is possible if you want to delete an object, you just very simply use the delete keyword and then it will remove that object from memory. And I think that's really kind of an important distinction is when you create an object, it doesn't get written to the hard drive, it gets written to memory, right? It's like a variable, it runs in memory, and then you can utilize it to do other tasks. If you create an object and you're done using it in your program and you need to do other things and free up some memory, you just simply run the delete command. That's not something that we will really do a lot of, but that's just something to have on your radar so that you know that you can actually do that, right? So if you want to just remove something from memory and free up that memory space. The other thing that's kind of interesting here, right, is this concept of kind of like almost like a cookie cutter approach, right? Like, and I use the example of houses in a subdivision where they all have basically the same house, right? But we can create this multiple versions of those houses, right? And that's what we're seeing here. So we have this class definition, albeit very, very simple, right? And then I'm using the constructor function to build one version of it called P1, another version called P2, another version called P3. They're all unique objects in memory. They all happen to share the same blueprint, right? And once again, this is a very, very simplistic blueprint, right? One data point, right? Not very impressive, but each one of them is unique. And carries with it all the features of the class. Later on, as we kind of keep pressing forward here, what you'll learn is that not only can you have all these data fields, but you can set those data fields externally. And then you can also have functions, right? Or capabilities or abilities, if you want to think of it that way, that the class can perform once it's instantiated. And that could be, once again, anything you can do in a program, right? You can do math, you can do output, you can run loops, you can, whatever, whatever it happens to be, that's built into the object, right? And it'll make more sense as we step forward here. But the fact that you can create multiple versions, huge, right? Because now whatever code was used to create that object, I don't have to recreate it, and that's the beauty of object-oriented programming. And then when I want to access one of its features, I use very simple syntax to either extract information or perform an activity. They make the little note here that each object is independent and has its own copy of the class properties, and that is correct. And technically, that X, which is just a data point, that we think of it as a property when we use it like this. There is also the pass statement, which we've learned to use in functions, for example. You can do that with classes as well. So if you know that you want to build a class, but you haven't quite got the details in there yet, you can throw pass in there just to make sure your program doesn't crash while you're waiting to figure out what you're going to put in there, right? So you're like, hey, I want to build a class for a person. I don't know what's going to go in there yet, but let's just throw pass on there and the program won't stop running. All right. Let's move now to the init method. And I want to be really clear on this as I start to talk about it. You can see this has got some pretty weird syntax. And it's like underscore init underscore parentheses, but super double careful here. These are double underscores. And one of the most common problems I see with students first doing this is they look at this really quick, they forget that it's a double underscore, they only type one, and then they just can't get anything to work with a class or an object, right? So be super mindful of that. That is a double underscore there. And this is kind of an important aspect of working with objects and classes. Now, those of you that come from other programming backgrounds, and I'll name either Java and or C#. Those are the common ones we teach here at Gateway. Whenever we're defining a class or an object in those languages, we put our data fields or the properties kind of the same way we're seeing in the examples back here, where we just say X equals 5, name equals Tom or whatever, that kind of thing. But that's really kind of abnormal, actually, for the way that Python does it. Python, instead, when you create the method, or when you create the object, excuse me, it uses this init method, whether it's there or not, right? So we saw like back here where, we were creating a class and it didn't have the init method, but we were still able to create it, right? But here, they're generally saying that it's better to use this init method. And then anytime you call on the class to create a version of itself, the init method will run, and then it will build the data that's part of the object. So for example, here we have basically a name and an age of a person. And those are, I think, common features of, a human being. And we use this like weird syntax. So a couple things I will point out. Whenever you have any sort of a method inside of Python, inside of a class, right? So, or, method is also known as a function, basically. So you see how we're defining basically the init function or method, if you want to call it that. And the first parameter inside any method inside of a class is always what we call the self-referring parameter. This has got to be there. It's required with Python. And basically what self means, if you're wondering, is that this method belongs to the current object that's utilizing it. So it's basically referring back to itself. Go, yeah, oh yeah, that's me, basically. And then notice here that when we do an init function here, it's also expecting two other parameters. So we don't like kind of count this one as a parameter, but when I call the person class externally to create the object, I want you to notice that we're going to feed in that order, a name and an age, right? Remember, Python doesn't care what data types they are. So what we send in is what it's going to become. A name obviously should be a string, and an age probably should be a number, right? So when we create the person, right, called P1 based upon the person class, this piece of information will land here. It'll go there and then populate self.name. So which name is it? The name of the object holding it, right? So now I would be able then to extract that information by simply calling upon those properties that are built in, or data fields. These are really data fields for Python. So it's very, very common when we define data fields to have an init function and to set their values very much in this fashion. And then notice how that self keyword propagates here. Once again, this is really a different variable than this, right? This is, I will call this anomalous, right? So if you learn C# or Java, we usually don't want to have this name be the same as that. Well, these two should be the same, but we wouldn't use the same name here that we use here. That's just like unheard of in other languages. And in fact, I was teaching a C# class the other night, and we demonstrated how it just doesn't work, right? In other languages, it won't work. In Python, once again, Python kind of doesn't care. I would caution you though, and my caution would be, even though this approach works, you might want to do stuff internally that might be more like, like this, and I would do that just to stay on the safe side. And that's partially a paranoia that comes from knowing other languages, right? This would still run just fine. You'll see it'll still output the same stuff, but the point for me is so that you don't confuse the pieces. Now, even weirder, right? And we'll demonstrate this as we do our exercises, perhaps, that if you do name things the same, and it is also possible to remove this self-referring variable. And I don't know if this will break it. It's been a little bit since I've done this. Oops, sorry, let me get the advertisement on the screen. And okay, so it does throw an error. It does not want you to do that because now it's not differentiating between them. But I also see people sometimes will just omit the self keyword, right? And then instead do something like do an underscore at the beginning. And let's see if that runs. I think that will run. Let's try it. Right. Okay. It doesn't like that either. But so it really does want the self keyword in there. Some people will take that underscore that I'm talking about and do it like this. Right. So this is a thing that happens once again to make sure that it's unique. So I think this will work. All right. Okay. So it won't. Okay. Okay. I'd be really silly about this. It won't work. Of course, now I realize why it's not working, because yeah, I have to do that, right? Because really the name of it is underscore name, right? So this will work, right? So this is a technique, and in my older lecture videos, this is kind of enforced, right? It's like the correct practice. I'm not necessarily saying it's correct, but I just caution you. I just want you to be aware of the fact of how this works. Um, and I think, if W3 is recommending we do it like this, it's probably okay to do it like this. That's kind of the whole point. So stick with the example, I guess. If I were to change anything really, I might change those. But you see, it still works. So if this syntax is cleaner for you, just stick with it. Right. No, it says the init method's called automatically every time the class is being used to create a new object. And okay, so we saw an example before that you can build an object without using init. And notice what it says here. It says without the init method, you would need to set properties manually for each object, right? And that is not a good thing. So generally, right? Not that it doesn't work, right? So this is kind of strange, right? So we create a class person, weird, and notice there's nothing in it, right? There's no definition of anything. There's no methods. There's no data, whatever. But I can still create one. It doesn't care, right? Python doesn't care. And then I can just create the fields externally. And now those are part of the object. That's a really weird approach, right? Generally not um, considered a good practice, but okay, weirdly, you can do it because Python is that kind of crazy flexible, you know. So, once again, if you compare to other traditional languages, completely not allowable. But in Python, it's like, okay, you want to throw a property in there? Yeah, go for it. You know, not a big deal. Using init, it says makes it easier to create objects with initial values. So, for example, right, we go back to this. Um, when we build this, right, this requires a name and an age upon the build, right? So if I did this and left these blank, I didn't throw anything in there, I'm not sure that it would necessarily run. It might. Let's see. All right, so it doesn't like it, right? So it does want some information in here. So you can John, and then maybe, John is 23, something like that. And then that will work. But this requires the parameters coming in. So when you do the create, you got to do this. Okay. And this is an important aspect of this, right? To know what the class file requires in order to do that. If you wanted, for example, to set a default value, there's a really weird way to do it. So one of the defaults ways to or apply a default value is right inside the parameter call inside the init method, you preset a value, right? This is kind of interesting because if I create Emil and don't send it the second piece of information, right? We're just assuming is 18. So 18 gets hard coded and that's what we get as an output, right? Notice the print statements here. And then with Tobias, we do know the value. So we just throw in 25 and then it becomes 25. So this makes it flexible. So you can preset a value going in. And then if you don't want to use that value, just throw the parameter in there on the way in and it'll set it to that. So pretty nifty approach. It is possible to have multiple parameters and we'll do stuff that's kind of like this, right? So if it's requiring name, age, city, and country, we throw those in that order. So name, age, city, and country, and all of those pieces of information would stick. And then in this case, come back to the screen. Right now, keep in mind, like we're just doing print statements here with this stuff, but I could take this stuff and do other programmatic things with it once I have it. It doesn't have to be a print statement, and I think you guys are probably pretty well in tune with that already. We do talk here formally about the self parameter, right? And when we start using this data point, right, basically, this field internally to the object. And here's our first example, by the way, of using a method other than the init method inside the class, right? So this will set our data, right? It'll build the objects and set the data, right? So when we run this command, that data goes here and builds the object. Also in the class definition, though, in this case, we do have another method called greet, right? Notice self is there, right? There's no other parameters going in. If there's more data that was needed, we could, put in a comma here and type in, whatever data, name or whatever it happens to be, and then use it in here. But if I just want this method to be able to output the name of the object, I think this is kind of an interesting thing. You can say, hello, my name is self.name, and you see the example already, and then you can add text to it if you wish, right? So you could let's do a \n here and say, and I am right, and I am X years old, whatever that is, right? And so I'm just altering that function a little bit to grab the other data point. And then, of course, what did I do wrong here? And I should probably read the whole error message. Can only concatenate string, not int. Oh, I see. Right. So age is an integer. So it wants me to put that inside the string function. And see, this is where string interpolation would be better, you guys, right? Because that would be a whole lot easier. But this will now run. All right, there you go. So this is basically reaching into the object itself, right? Pulling the name field, pulling the age field, converting it to a string. But here's an example. Now, instead of, saying p1.name and printing it, right? The print command's built here, and we just call on the greet method, which is part of the P1 object because the P1 object is built on the person class. And we can now invoke a method inside of it to perform a task. In this case, it's just putting stuff on the screen, but can be much more complicated. The self parameter must be the first parameter of any method in the class. So like anything that you build inside there, that's a method, AKA function. Self always has to be the first parameter. Okay, it says, why use self? Without self, Python would not know which object's property you want to access. So in other words, you're calling upon the P1 object to pull the name out of it, right? What if you skip that, right? And you don't know, then it doesn't know which of the objects that it created from the blueprint to pull the name from. And it links basically back to the specific object. I don't really think I need to demonstrate it. Another real notable thing, and I don't think this is really a good practice, by the way, self does not have to be named self. You can name it whatever you want. Like you can call it my object. You could call it this, which some people do, right? Because that's the self-referring name we use in like JavaScript and Java and C# and all those other languages. So some people will throw this in there because that's what other languages do. I would really strongly caution you on that, right? And I just really careful in that situation. They do give an example here of using the words my object and ABC instead of self, right? Like, so here they're using object and here they're using ABC. And the only reason I can really think about doing that is maybe it makes your syntax easier here. And notice the caution, right? Note, while you can use a different name, it's strongly recommended to use self as it is the convention in Python and makes your code more readable to others. And I think that is important, right? Especially if you're working in a team environment. So stick with the self, and that becomes helpful. Here they have an example. And interestingly, we will do an exercise with cars where we are setting a brand, a model, and a year, self-brand, self-model, self-year. And then we can display the info. So it's really common. This is a really common thing to do, is just to have a display thing that shows what you're dealing with, right? In the object, just to, okay, what's in the object? All right, display it, and so here we build the car with those features, and then we just display info, and there it goes. Now, what's kind of neat about this, and I want you to think about it, like if I'm building a car, right, and I call it car one, and normally what I would do is I would like name it, whatever the car is, and we do display info. Notice, like, if you name your methods in a really clear way, the method call describes what you're doing. So this is another reason why objects and classes are really useful, right? It's like, all right, car one, display its info. I mean, it just makes sense, right? And then you don't have to worry about the nitty gritty tasks that make it happen. It just happens, and it makes sense because it's almost like plain English, in terms of what you're doing. If you're calling methods that have self within them, it says you can also call other methods within the class using self. So this is really kind of an interesting concept, and I'll have you look at this code here really quickly. So we build a person and he's just got a name, right? And then we have this greeting method that says hello name, like hello Joe, or whatever person's name is. And then we also have this other method within it which can call the function within here, right? And so what this one would do is it go within itself, look for its greet method and it'll say, hello, Joe. And then Joe, welcome to our website. Joe exclamation, welcome to our website, that kind of thing. And if you want to see that, you can just click the button and run it. Not really a big deal. All right, let's now start talking about properties, right? And when we talk about properties, what we're really talking about are variables that belong to the class. So like we've looked at this enough already where I think you kind of get it. That self.name is a property. And I'm going to use the syntax of data field, right? Also, right? So it's a kind of like an internal variable, if that's a better way for you to think about it, but it's a variable that belongs to the object, right? And we call these properties as well, right? So we call them properties, we call them variables, internal variables, I think is a better way to think about it. And then we also call them data fields, right? And normally when we do an init function like this and we define our data fields or properties or variables or whatever, it's usually the first thing in a class structure, right? We usually put that up at the top so you can see what data you're dealing with or what properties you're dealing with, right? And we can access the properties using their name, right? So whatever object you create and then dot its name, and that will just pull back that value, right, for whatever purpose you need. You can modify properties, right? So if, for example, when I create this, Tobias is 25 and that's built into the object and I can print that out. But then, you know what, eventually Tobias is going to become 26, so I can go in there and I can change that like any other variable, right? So really what we're doing here is we're changing the property or variable age inside the P1 object the same way I change it in any other variable with an equal sign, right? Whatever's on the right is stored in the thing on the left. P1's age property will receive that value. Right? So pretty basic, right? Another thing that you can do is you can delete the age, right? So like if I delete that portion or that property, and this is a pretty important one, and I don't usually recommend doing this, by the way, but it is possible to do it, is I can create this object with a name and an age, and then I can actually delete that property from the object. So there's not like an empty variable now. No, it's just gone, right? You've removed it. So therefore, strongly recommended you don't do that one at all. All right. So kind of interesting little combo here, right? So we have what we call class properties and we have what we call object properties. And notice it says that properties defined inside the init method, right, belong to each object or instance property. So like when I create, a car and it's a Toyota and it's got a certain model year, that belongs with that object. It's kind of like a house that has, a red roof and white siding, for example. But properties that are defined outside the init method belong to the class itself and are shared by all objects. And I think that's pretty intuitive. So anytime I create a person, I will declare them species human because that's appropriate, right? So it does make sense. So these are what we would call, instance properties. So they belong to the object itself, and this belongs to the whole class, right? And it's still part of the instance. Like so, and this is kind of terminology we should talk about as well. That every time I create an object based on a class, we call the object an instance of that class. And the process of creating an instance is called instantiation, right? A hard word to say sometimes, but instantiation is the process of creating an object from a class definition. Each unique object is an instance of the class, right? Important terminology. We can, of course, modify class properties, right? And notice, for example, if I'm creating persons and I have a last name field that's blank, I can go in there and I can change that, right? But now what's kind of interesting is both of these individuals would end up having the same last name, because, you know, I'm setting it on this level, right? Um, if I change an individual, person's regular name, it is not going to change their last name. So that's just kind of to do that, right? Another thing that you can do, and you may have already figured this out, right, is if I can go in there and I can delete a property and it's just gone from the object, and then you already saw before that if I create an object with no properties, I can add a property later. Well, yeah, you can do that with more complicated objects, even if there's an init method. And I decide, you know what, it would really helpful to know what Tobias's city is. I can just do that. I can just create the property, brute force. And mind you, once again, if you compare to other languages, you just simply cannot do this. The definition is the definition. You can't add a property after the fact. Python, however, super flexible, totally allows it. And it, kind of frustrating for traditional programmers, but also kind of empowering at the same time, right? Adding properties this way only adds them to that specific object, not to all objects of the class. Okay, so that's important, right? So none of the other persons would have a city property, and especially not one with Oslo. All right, we are now going to look at methods, right? We've done this a little bit, and this is the example that we looked at, where a class definition can also include a method, and then externally, we just call the method by attaching basically a function call onto the object name with a dot. So we just say, what's the object? Dot, what method inside of it do you want to run? And it just works, right? And we've learned this already, that the first parameter of any, method or function inside of an object has to be self. So this is just kind of reinforcing it. Maybe this is a little bit better example here. And I'm going to go to the next screen here to look at this, where we have basically a class called calculator. And I want you to notice we don't have any data fields here, right, that we're storing internally, right? This there's no init and there's no object properties or anything like that. We just basically have two functions or methods inside here. One adds, receives two numbers, and then adds it together and sends it back. Another one multiplies and then multiplies the two numbers and sends it back. So when I create a calculator object, I'm calling it calc. And then I say calc, add 5 and 3, calc, multiply 4 and 7. And provided that we're sending the information incorrectly, it'll just perform it. And this is kind of interesting. So we can actually create objects that perform tasks only. And this is kind of an interesting thought. And I'll have you think about this. When we call in, for example, a math library and we run a square root, or we call in the random number generator and it creates random numbers, that whatever, those tasks are, think about the syntax that you use, right? So you call math and then you call like square root sqrt, and then you send a value to it and then it gives you something back. It's not storing it inside of its object that we created. In fact, we're not even creating an object. We're just using the capabilities. So this really kind of demonstrates two things: that you can have kind of just functional things that a class does and doesn't even store values, but the fact that you can have it kind of do stuff and return a value right away. Of course, because these do return values, you got to put it somewhere that can deal with that. A print statement is one way. So if it's returning something, well, heck, we can print it to the screen. If it is to store something, I could instead, put a variable name here, say equals calc.add53, and it would store it in the variable, and then I could print the variable or do more math with it. Right? So those are all capabilities. When we can use this approach here, which says methods accessing properties, it says methods can access and modify object properties using self, right? And so we've seen this example already, right? And this is a really common thing to do, is to have something called get info. And there's this terminology. So I guess we should probably talk about this, because if I learn how to do objects and classes inside Java or C#, often what happens is we write methods that allow us to set the values of the properties, right? So we call those set methods. So like if I wanted to set the name, I would say set name, right? That's what I would call the method inside the class. And then I send it data and it sets it internally. Or if I want to return the info, I often use the word get. So I'm getting the info from the object. And in this case, this is an example of a get. So that terminology comes from older school programming, and we call that feature, by the way, getters and setters. So get information, you're just retrieving it, or set information, you're putting it in. So in a way, when you do an init and you're sending values to it, you're setting values right off the bat, right? So this we've seen already too, that we can take information from the object itself, that whatever these are set to, and then use it inside of a method to do other tasks. If I want to, for example, celebrate a birthday, right? So this is a great little function if you think about it, because we talked about it before, like Tobias was 25, eventually he's going to become 26, right? So if you have that person and then you celebrate their birthday, and think of how like the naming makes sense. Well, you're adding one to the age, and then you can say happy birthday and you're now 26, so that's kind of the point of that. There's also another important kind of we'll call it a default method that we often use inside of Python, called the str method. And it says it's a special method that controls what is returned when the object is printed. So for example, here's an example of taking this object. Okay, so we have like an init function with name and age. We build the person called P1, and then I print it to the screen. And then we talked about that before. And remember, like before, when we printed person, and in fact, let's do that. When we print the class name, it tells us, well, hey, that's a class, right? And then when I print the object, it tells me, hey, that's an object. And notice, an object based on the person class. Interesting, right? But it doesn't really show us any of the information inside the object. The whole point of the string method is if somebody tries to print the object directly, the string method would kick in and provide default information instead. So if I ran it with the string method, right, I can see that Tobias is 36. Okay, and you're wondering, where did the parentheses come from? Well, they hard coded them in there. That's where it comes from. So this is a really common thing to add, and I wouldn't call it obligatory, right? But we kind of consider this a courtesy because, like if somebody's like, okay, what's in this object exactly? That's a question people might ask, right? And if you don't know the properties, like let's say, this class file, this isn't a separate file and the user can't look at it. Well, they can't then do this and figure it out, right? So this is considered a courtesy to have a string method. Once again, when you do these, right, super mindful, double underscores in both of these positions, really important, right? Some people do this as a default, just as well as they do this as a default when they're making classes and objects in Python, right? I don't know if I do a lot of this in like the homework demonstration, but maybe I'll make a point of doing it, when we start going through the homework. Classes can have multiple methods that work together, right? And this is kind of where, you're using different functions logically, just like you would in a program. So like if I was creating a program that had a bunch of functions, it's totally allowable for one function in my program to call another function. Well, the same is true inside of a class, right? If you look at this example here, and this is, I like this example. This is a little bit higher level, right? And in fact, let me just go into the code a bit. And you'll notice here how we have basically one parameter, which is the name. So, and notice, what are we building? We're building a playlist, like to play music, right? So what are we going to call the playlist? I don't know, on the road part one, or something like that, right? And then you also create, notice here, what does this designate? Well, that's an empty list, right? So self.songs, we created an empty list inside my playlist, whatever name I gave it, right? Then if I externally create that playlist and I call it my playlist, then I can go ahead and run the method called add a song. So I send in the song name. I use the list syntax to append a song to the list. And then I'm also putting a message in there. Hey, it got added, right? Then I have another one which removes the song from the list. And of course, this one checks to make sure it's there first, because otherwise it doesn't make sense to remove it, right? So if the song is in the list, remove it, right? And then it gives you a message that it's removed. And then we also have one that just shows what songs are in the list, and it just does a print, right? And then it gives me the whole breakdown of the list. So we add a song, and let's just play with this a little bit, right? Because you already see that output. And how about we add another song, and we'll just call it, Happy Birthday or whatever, think of the song name. Usually I'll throw in a Beatles song, right? Let's just go ahead and do that. And we've been working with that one in code, and yeah, it's lowercase, whatever. All right, so let's run that. I'll just show you that I was able to add 4 songs, and then when I show the songs, you can see them back on the list. Okay, great, works wonderful, right? And maybe we'll do a slash in there to push that output down a little bit. All right, but now I could run this code again, and I could do my playlist dot remove song, right, which we didn't try before, and then I would have to throw in the name of it. So I'm going to say Stairway to Heaven, and it doesn't have to match exactly, right, to be removed. And then when I show it again, so that should be removed from the list. All right, there you go. All right, so this is a really good and practical example, right? So it shows us a bunch of different really important features here. One, that we have our data fields. One of those data fields can be a more complicated object like a list. And then I can have multiple capabilities. And notice how the playlist, what we're calling it, it makes sense to be able to add a song, to remove a song, and to show which songs are in there, right? All of those are super, super helpful. All right. It is possible, if you wanted, to delete a method. Once again, I would highly recommend against this, because if you don't, like, you create a playlist and you never want to be able to, let's say, remove a song again, you could delete the remove thing, right? And that playlist is like locked forever. Well, as long as it's in memory. But once again, that possibility is here. So if you don't need a feature, you can kind of save on a little memory by removing one of the methods. I, once again, strongly recommend against that, just generally speaking, because that should be part of your design approach. All right, last topic we're going to look at here is what we call encapsulation, right? And encapsulation is really about protecting the data that's inside the class, right? So it says it means keeping data properties and methods together in a class while controlling how the data can be accessed from outside the class. This prevents accidental changes to your data and hides the internal details of how your class works. So this is something that, like, once again, comparing to other languages, because it's important, because a lot of you do know them. But if you look at a traditional, like, C style high level programming language like Java or C# or C++ or something like that, we have properties that we can set to private. And in those languages, we actually use those keywords. We say private, and that means anything outside of it can't see it or change it, right? Well, we can give the information back by using methods, but typically you cannot mess with it. If you want to make something private, you basically use a double underscore prefix in front of the word. or the variable name. So like this, for example, turns this into a private property, right? So if I go to try to print this out, it will throw an error. So let's just see what the error looks like so you're familiar with seeing it, right? Um, but this is set to private. We're not allowed to see it, right? So I can try to print it. It will just throw out an error. The name will come back, but the age will not, right? So that's pretty darn important. And it says private properties cannot be accessed directly from outside the class using the simple syntax that we've learned, right? What we do instead, right, is when we set private properties like this with the double underscore, we then sometimes will write, and here's that syntax again, get and set. In this case, we want to get the age out of the object, but the only way to get it is by using this method. The method is accessible to us, right? That's not private. And then that's got the capability of returning the age, but only via the method call. So when we run this, you will see that you do get the age back, right? But only by virtue of calling this method, which sits inside the object, and that method has access to the private field, right? So very, very helpful. The other piece that they're not really showing here is I also externally cannot set the age, right? That's hard coded, right, at this point. If you wanted to set the age, all right, so, you know, kind of logical that this would follow, you can also do it with a method. So, you know, and they have a little bit of logic in here, but basically you're just sending the new age in. It says if age is greater than 0, then age equals age. Otherwise, print the age must be positive, right? But we can set the age, right? And what they're really doing here is when we send in this value, they don't want us putting in a negative value because that just doesn't make sense. That's what the if statement's about. But otherwise, this would set the age. So when we run it the first time, when we get the age, Tobias is 25, then we set the age to 26, and then we can get the age. Now, once again, set age has access internally to the object to this private field that we cannot otherwise adjust, right? We call set age, send it some data, then that can change the property. This approach is very, very common. Once again, like setting privates in other high-level languages. Quite often in Python, we kind of forgo that, real frankly. But if there's a programmatic reason you don't want people messing with things, this is how you do it. Double underscore in front of the name. Okay, so that's a important thing. One of the things that they talk about here, and I think this is important to add, is it says why use it, right? It provides a few benefits, and I think they detail them nicely here. Data protection. It prevents accidental modification of data. You can also validate data before setting it. So this is, I think, probably the most important reason why. So like looking at that age before made sense, right? So like, what if somebody like mistakenly types, oh, I'm negative 25, you know, it's like, no, you can't do that. You can't be a negative age, right? And the other things you could do is you could check to see like, okay, did they type in like something silly like a floating point number, you know, whatever, right? But in principle, right, you can check the value of something before it's set. Whereas if you use the other original approach that we learned, you can just set it, and if it's wrong, it's just wrong and it's there, right? So maybe not what you want. It's a lot more flexible. It says internal implementation can change without affecting external code, right? So like you can control the mechanics of the data on the inside of the class without worrying about writing code on the outside of the class to control it. And it says you have full control over how data is accessed and modified. And that terminology that we talked about, once again, to set and get, setters and getters, right? So getters return information, setters use whatever logic they use to set the information, and therefore protecting, you know, that private data field. It is also common, by the way, and I talked about this like our old textbook really pushed this quite a bit. It says Python also has a convention, not a rule, right? Convention for protected properties using a single underscore prefix. Um, Here's the difference though. The double underscore actually protects it. The single underscore is just letting you know that really you should mess with it with this. That's what it's saying. But you might, so if you really truly want to protect it, double underscore. If you want to imply that it should be protected, you use a single underscore. And I think in most of my examples, like my older exercise videos, because our old book pushed it so hard, that's kind of like the practice is you always use a single underscore. The other aspect of it is you can identify very quickly that it is an internal variable, um, although this is too, right? So really, there's no functional difference between these, except the implication is you, really, you shouldn't really mess with this. That's the implication, right? And it says the single underscore is just a convention. It tells other programmers the properties intended for internal use, but Python doesn't enforce this restriction. Right? It is also possible, if you want, to create what we call private methods. I don't think we will do any of this in our homework, frankly, but I just want you to be aware of this. So when we create a double underscore in front of a method name or a function name inside of a class, that means the only way that it can be used is internal to the class, right? And they give a little example here of how it works, right? So like this one here is a calculator, and they have one data point, which is the result, preset to 0. They have this validate thing. And what they're doing here is they're trying to figure out if something is going to return true or false, basically. So if not is instance, right? So we're looking for basically a number, and is it an integer or is it a float, basically. And what we're doing here is we're calling that function internally, right? And if the number is valid, then we'll, do the math, basically. If the number is not valid, we can't do the math. So like we send in text, basically. But, so the point is, right, we run the calculator, we add a number, and then we show the result. So that should show 15. But if I try to validate if 5 is a number and I try to run it externally, it won't run. It will only run relative to a function inside. So this is a private method. I can't call it externally to validate that that's a number, but internally it does it because it needs to, right? And so this is, once again, a design thing, and I don't think any of our homework will touch that, just an awareness thing. So the validate method or the internal private methods can only be used by other methods inside the class, never externally. When, and this is kind of, our last little piece here from W3, by the way, it says name mangling is how Python implements private properties and methods, basically using double underscores, right? So double underscores makes it a private property, or double underscores makes it a private method. And notice what it says here. Python automatically renames it internally by adding class name in front. So for example, age becomes underscore person double underscore age, right? And that's what they're kind of referring to. So Python mangles the name. Once again, I don't call this a big concern because I never ever do this, by the way, and I've never really seen anybody else do it. But they are handling it. So like, in other words, this is really what's happening in the background, but really you should not use it, is what it's telling you. So I kind of, wonder why they show it, but it says here, while you can access private property using mangled name, it's not recommended. It defeats the purpose of encapsulation. So in other words, what is normally private, you can access if you know the correct name, right? But you really shouldn't. So don't. basically. All right. Last little lecture piece here is the last little bullet, which is this one here, which talks about designing, implementing, and testing classes. So, you know, when you're learning how to program at first, you might not see any reason to create objects and classes. But as you get more advanced in your programming, you'll see a lot of reasons to do it. And first of all, think about what it is you're trying to create with your code, and especially if something's used a lot, right? So I might think of like some sort of an object, okay, like a rectangle or a house or a car or a person, right? Figure out what data it needs. For example, with a rectangle, well, rectangles are defined by width and height, right? So they're a certain width and they're a certain height. Decide what operations it should do. Well, a rectangle, by virtue of being a rectangle, will have an area and it will have a perimeter. Those are mathematical calculations. So that could be built into the class definition. So if I was to build a rectangle object, I might do something of this nature where I build a width and a height for the rectangle, and then I might have a method inside of it that returns the area. I might have another method inside of it that returns the perimeter. I might have another one that's a string method that shows the properties, that type of thing. And then after you create a class, then you want to instantiate it. So like here's R, which is a rectangle. We send in width and height. And then when I look to extract information out of it, I can, like, for example, return the area, and then you'll get your result. But this is just a very primitive example, right? When you start to really break it down, there's a lot of things that can become objects and classes in programs, and especially if you have to reuse something many, many times, right? And that's really kind of one of the keys. I do want you to also remember that when we build objects and classes, I can create a class definition, such as this one, and place it inside of my program, right? Right in the same file. That's one approach. And I think when I do the homework, I'll probably demonstrate both approaches. Or the other approach is I put it into its own file. And I want you to notice if it's called rectangle, I would call the file rectangle as well, right? And then from the program that's going to use it, I would import it like I would the math library or the random library or any other file. So that will kind of cap lecture here, folks. And I do want to also point out that one thing I did in this unit that I don't normally do is I had a couple of practice exercises here that might help you kind of ramp up your capabilities. So I would highly recommend that you do this, right? And so one is to create a book class, and then, with properties, title, author, and pages, implement the class, create two objects, call summary on each object because they want you to make a method called summary. And then they have another one here that's a bank account with encapsulation. And by the way, these are both very classic programming problems to teach, the classes and objects concept, because you think about it, right? A book is a thing where you might have many, right? And the features of a book or the properties of a book are usually pretty consistent, right? So that's the type of thing we're talking about. Also, a bank account is really a good one too. And we, what do you do with a bank account? Well, you put money in, you pull money out, and then you figure out how much money you got left, right? And these are fun little exercises. And I've been kind of also contemplating maybe turning these into extra credit, but I think maybe what we'll do is we'll just use these as examples in class. But if you play with these a bit, you will see how to do it. Just to help you out, right, I would recommend with the practice exercises that you do try to build them. And then if you click here on the title, I do have solutions, right? So examples of how to do it. And you see there's not a lot of code here, but it shows you how to build it and what the correct answers are. So my suggestion is read those, try to do them on your own, and then look at the solution and compare, right? And see where you might have been a little bit different. All right, folks, that caps the lecture here for Unit 9, and I will see you all in class.